this connection we're going to show here is going to be probably the most common single phase connection that you will make in your career as a line technician. And it will be a single phase 120 volt slash 240 volt 3-wire connection. And we'll connect this to a Y primary circuit again, and let's just use an example of a 2400 4160 Y circuit in this instance. So again, we need to go out to the transformer yard, find the transformer that will work on this particular application. And so we're going to need a transformer that we can connect to this primary system, and that transformer is going to have a rating on its nameplate that will read 2400 4160. For the primary voltage, and 120 slash 240 volts for the secondary. So in this case, the nameplate rating actually matches up with the voltage that we actually want to get out of this particular transformer. So once again, as always, let's mark our polarity marks. Again, we'll make the assumption that this is an additive transformer, so the secondary bushings are X1, X2, X3 right to left. And let's connect the secondary coils inside the transformer. And in this case, we need use of the full length of the coils tied together, so we're going to connect them in series. In other words, just connect them end to end to make one long coil, show the connections coming down to the bushings themselves. And we utilize all 3 bushings on the secondary side. Good idea when you're making these drawings to take care of the important things such as grounding, showing our grounds. The same is true in the field when you're making the connections. Probably the most important connection you can make is the tank ground, and also to assure that the neutral is tied in with the grounding system as well. So let's go up and make our primary connection. And again, this is a Y connection, so a Y connection can be described as a phase to neutral connection. So I need to take one phase into one primary bushing, and the other primary bushing will be connected to the neutral. So I'm going to just take B phase this time, and I'm going to connect it into the H2 bushing. It doesn't matter which bushing you connect it to. If you have a transformer that has 2 primary bushings, you can use either one. And H1 then in this case will come down and connect to the neutral, and that will take care of our primary connection. The secondary connection is a 3-wire connection, which means we need to connect from the transformer. We need to connect to 3 different wires on the secondary system. So the X2 in this case will be the neutral. So we'll bring that down to neutral. And then X3 can come to either line 1 or line 2. It doesn't matter which one you bring it to. X1 will go to the other one, in this case line 2. So now we have to determine what our voltages will be when this transformer is energized, from neutral to line 1. If you're not sure what these voltages are, the best thing to do is follow them back to the transformer. So the neutral, follow it back, we end up at the X2. And line 1, if we follow it back to the transformer, we end up at X3. And we see that measurement then, the voltage is half of this coil. Half of this coil should equal 120 volts. Line 1, or neutral to line 2, we have the same situation. In this case, we're measuring voltage from the X2 to the X1 position. Again, half of the coil should equal 120 volts. And then the voltage between line 1 and line 2, if we follow line 1 back, we get to the X3 bushing. If we follow line 2 back, we get to the X1 bushing. So we are measuring across the entire coil from X1 to X3, and that should be 240 volts. So I always want to fill in those readings up at wherever the case, whatever the case may be, where they want you to, whatever the sheet. Some sheets are going to look different than this one, but there should always be a place where they want you to put the voltages on the secondary side and so forth. Like I say, this is probably the most common single phase connection that you could make. Now let's take this one a step further and let's change the connection so that instead of it being a Y connection, we're going to have to connect this to a delta circuit. So if we have a 2400 volt delta system instead of a Y system, we have a delta system, we have to change our connection a little bit on the primary side. Now, nothing's going to change on the secondary side, and the transformer that we have here, since 2400 volts is the only voltage on the delta system that's going to be available to us, with this transformer, we can use the same transformer in this case. What we have to do differently is how we make our primary connection. That will be the only thing that will change in this case. So I'm going to erase the primary connection down to our neutral. And now, in order to get 2400 volts across the primary coil of this transformer, I have to connect to two different phase wires on the primary side. So I'm already connected to B and to H2. So if I take and run a jumper from C phase down to H1, now I've created a delta connection on this single phase transformer. Nothing else changes. The secondary will be connected exactly the same way. The transformer tank is grounded, neutrals are grounded. It's just that in this case we have a delta system instead of a Y system that we're connecting to.